Hi, welcome to the CIDCI online salon series. I'm Margie O'Driscoll, and on behalf of the CIDCI Board of Directors, I'd like to welcome you here today. CIDCI's mission is to accelerate change in the built environment by convening innovators for educational programs. We also serve as a trusted source of information about innovation. Special thanks to all of our sponsors who make this possible. Today we feature Dr. Forrest Flaker. Forrest leads digital project and system development at Katerra, a technology-driven off-site construction-based company not very far from here in Menlo Park, California. Previously, Forrest was part of the research and teaching team at Stanford University Center for Integrated Facility Engineering, and has practiced as a structural engineer for Arup in London and San Francisco. Board member Zig Rubel will fire off questions for Forrest, and we encourage you to do the same. Welcome, Forrest.
Thanks very much, Margie. Thank you for the introduction, and it's a pleasure to be able to speak today. I'd like to make it as interactive as possible, so I think we might get some questions from Zig, but if anyone from the audience would like to interject as I'm presenting, feel free to do so. So what I'd like to discuss here today at the audience is the idea of localization and how that can be addressed in an industrialized construction context. The notion of product versus project. I think there's a lot of interest in the industry in general on this topic today. So hoping to, I would guess, raise some ideas of where I and my colleagues at Katerra think the industry is going, and some of the strategies that Katerra is employing to tackle those opportunities. So I'm going to spend, I think, most of the audience I would expect is generally familiar with Katerra, so I won't spend a lot of time just giving a really brief background on what the company is about for context, and then we'll get into talking about those opportunities. So quick background on Katerra. It's grown to be quite a large business, founded in 2015, over 8,000 on staff today in the US, Saudi Arabia, and India, and quite a diverse set of backgrounds in terms of where people are coming from that have joined the business. Different technology companies, supply chain businesses, which at least for me, I'm coming from the building industry, as Margie mentioned, from building engineering. Quite interesting to sort of learn from these different expertises, but as you might imagine, also quite challenging in that people are coming with different sort of ideas, approaches, and vocabulary. So that's been I think a challenge and opportunity in terms of making those backgrounds work together effectively, but definitely hope to discuss that in a little bit more detail as we get into the discussion. In terms of what the products and services Katerra provides, it's sort of a turnkey design, fabricate, assemble on site, some material supply, and then a technology component.
So Forrest, I had a question about
Sure.
that. Is there anything that Katerra is currently not doing and wants to do? Because the list looks pretty comprehensive.
Yeah, so there was, I would say, the company has gone through a little bit of change of direction with a new CEO coming on board in July of this year, Paul Klipsgaard from Schlumberger. And I think previously materials was a big focus of the company. And I think that is less so today in terms of actually sort of designing our, materials like, lighting or bathroom fixtures. We were looking to provide those materials and fabricate them ourselves. And we've kind of moved away from that portion of it. We're still doing the manufactured assemblies. So wall and floor panels and trusses and things of that nature, but sort of the fundamental building products like, HVAC systems or other materials of that type, we're no longer actively involved in.
And is there anything that would never be on the list and that Katerra would want to partner with other companies for?
I mean, the development and operational components of the building life cycle are not, I would say, something that Katerra is actively looking at. So, you know, so partnering, you know, developers are essentially our customers, and there's not really a strong interest in terms of operating buildings currently. So those areas I think are partner opportunities.
Okay, great. Thank you.
Sure. So this is in terms of market experience. Some may be aware, Katerra has grown a lot through acquisition, largely through general contractors, regional general contractors across the United States, and a precast supplier, KF Infra in India. So we have quite a large portfolio of different building or market types that Katerra is currently involved with. In terms of the sort of vertical integration where we're designing, fabricating, and assembling, currently we're focusing on multifamily and commercial with our CLT product. So that's, you know, that is the sort of current vertical focus, although we're acting as a GC for all of these different building types. You know, one of the ideas is to, of course, move as much of the construction into the factory environment. So what you're looking at on the left is our factory in Tracy, which does components and finishes, so wall and floor panels, light gauge steel, and timber. We have a mass timber factory in Spokane, Washington, that produces CLT panels, and then the precast facility in India that does volumetric precast concrete, largely housing units. So as kind of a transition, you know, I think it's important as sort of, you know, I'm on the technology side to really think, rather than focusing immediately on the tools or technology, you know, where do we think the industry is going? And so this is an analogy. So the targeting systems of the Spitfire airplanes in World War II, when they were first mounting machine guns on airplanes, they realized that the pilots were having a difficult time hitting the target because the speed of the bullet relative to the speed of the airplane meant that they effectively had to lead the target. And so they developed this kind of crude analog targeting system in which, like, the pilot would have to, like, press essentially a button indicating the direction of the plane and then adjust the size of the circular targeting based on the range, and that would essentially automatically, like, have the guns lead the target. So the idea is, if we first need to kind of understand or agree on where we're going as an industry, where the opportunities are, and then technology is really just a tool to address that. So I'm going to make 3 claims of where I think the industry is going. Some may be more controversial than others, but just interested in the audience's view on whether they agree with those assumptions or differ. And then I'll talk a little bit about the technologies that we're using to capitalize on those opportunities. So the first is perhaps the least controversial, is that, you know, construction is industrializing. If you look at, this is housing prices in the US, not including the price of land, and normalized for inflation. So you're seeing the relative cost of housing going up over this period, this 50-year period of time or so. And the relative percentage of where that cost comes from has remained relatively constant. You know, but generally a relatively even split between materials and labor, with a relatively high labor component. If you compare that to sort of other products, so this was particularly relevant. I mean, most may be aware, but the founders, two of the founders of Katerra were coming from a company called Flextronics, which was a contract manufacturing firm, made a lot of electronic semiconductor equipment. And so if you look at over that same period or a shorter period, the relative cost of these products have actually gone down. And a lot of that has come from more efficient manufacturing processes and new materials. So if you look at, for most of these components, like the labor component of the total cost of the product is somewhere under 20%, and in some cases under 10%. So the thinking is, of course, can we apply some of these principles in advanced manufacturing to buildings? I think there are many in the industry that are looking at that. So not, I think a common practice that you see a lot. In terms of our approach to do that, you're looking at one of the multifamily products. I think this is, again, also pretty typical, but we have standardized unit plans that are sort of modular and can be combined into blocks or what we call chassis. And those sort of 3 chassis make up like a garden style apartment. And so that type of modular design enables you to have many different unit mixes that all fit together to meet like a pro forma. And so that's I think a general approach. I think that's a common one for multifamily housing, but Katerra is also taking that approach to maximize reuse and sort of configurability of the building products.
So Forrest, one of the questions that I had when looking at your deck is, can this platform approach be used for different building types? I see that, you have a diverse set of solutions for multifamily, but could you use this for, let's say, retail or office space?
So I think, in principle, these principles I think can be reused. You have to think about what the module is. So for like commercial office, it largely centers on like the bay, right? And so, for example, for the CLT product, I don't have a slide here for that, but it's very much centered on sort of the CLT panel composition to achieve different bay sizes in a commercial setting. So similar approach, but in this case, instead of the unit being kind of the atomic module, it's the bay.
Okay, great. Thank you.
I think that would apply to other other building types as well. So this is kind of a perspective. I think there's been a lot of debate at Katerra around, and I'm sure in the industry in general, around the level of standardization that should be achieved or is necessary to achieve in a manufacturing context. I'm going to make an argument for mass customization, and the reason for that is I think the unique environmental and market factors in building construction that demand kind of a higher level of customization than you might have in other product types. So this is a seismic map, which is indicative of sort of the lateral forces that a structural engineer might have to design for across the country. So one of the early exercises when we were developing the multifamily product is we automated the structural design to look at what the cost of the building would be in different zip codes, ranging, across the country. And maybe this is surprising or not, but basically it was a factor of 2x, basically, roughly, in the total cost of the structure, depending on where the building was located. This is just material, so not like, not dealing with the market factors of labor. So when you start thinking about how standardized you make the product, even if you're looking at like tiering a building by, say, seismic zone, if it's 100% difference between the lowest and the highest, you start realizing that you're giving away, say, relatively large margins by sort of designing to a bucket rather than designing to specific site conditions. and so that was an interesting learning, I think, particularly for those outside of the building industry. The second factor, of course, is climate zones. So we did a similar analysis for MEP systems. This, I would say, had less, the choice of systems had less of an impact on the capital cost, kind of like, roughly like a 30% factor according to our analysis. But if you look at like operational performance, it was almost equally significant, right? In that certain types of systems would not perform as efficiently if they were more standardized. So depending, on your interest in sort of the operational phase, it was also quite important to develop customized systems. And the final was, of course, market factors and labor rates. These numbers are not correct. This is just an indicative figure I pulled from the internet just to give an idea of, I think, most people in this audience, I imagine, are, understand these labor rates, but we, roughly, I would say at least like a 2x difference in labor rates, depending on where you are in the country. And why this is important is when you think about the level of completion that is sort of cost optimal to achieve in the factory, that may vary, depending on where you are in the country. Obviously, if site labor is cheaper, you may choose to do more on site versus, markets like the Bay Area where that is relatively expensive. And so when you're thinking about the product, you want to allow some customization or configurability to allow for various levels of completion in the factory or the field. So that's sort of, an argument to explore how do we enable sort of a product that can be efficiently customized to these unique, environmental and site conditions.
So Forrest, before you go into that, does Katerra see a reduction in labor for both on-site and off-site using your approach?
So definitely for the off-site. I wouldn't say, I mean, by the fact of completing more work in the factory, you of course reduce the amount of labor that would come on site compared to a sort of traditional stick build. But I would say that right now Katerra has not developed any like on-site practices that would reduce labor compared to a sort of conventional project. It's only by the fact that some of that work is done in the factory. There's no sort of innovative on-site practices that would reduce labor.
Right. So I think what I was trying to find out, and it may not be possible, but if you built two buildings that are somewhat the same, one was the Katerra method and one was the traditional method, would the Katerra method have overall less number of hours to it, or would they be about the same?
Yeah, so if I understand that question right, you're saying that, I mean, there of course is some learning on the labor side where if you're doing repetitive tasks, you're more efficient. And so there's definitely a benefit for that in that, for example, Katerra multifamily developments, we only have, say, 3 or 4 different chassis types that are repeated in various configurations around the building. And I think there definitely is some significant learning in terms of labor efficiency there. But I think that would be similar to other types of sort of like track developments where you're doing sort of repetitive building types.
Right.
Yeah.
Okay, great. Thank you.
Sure. So in order to kind of achieve that idea of developing a mass customized product, Katerra has invested a fair amount in technology to support automated design in a couple of areas. And I'd like to talk a little bit about that. If there's anyone in the audience who has worked for either manufacturing business or vertically integrated company, what I understand current practice is usually you have an architectural BIM model that's used to produce documentation, permit drawings, but it hasn't really been conceived of as a fabrication sort of asset. And so often a fabricator will essentially rebuild that 2D documentation to create a fabrication level of detail where you have the location of every component precisely determined in a way that would be suitable to build. And that is a pretty time-consuming effort. Per garden style kind of 24-unit building, Katerra is investing over 1,000 hours just in sort of that fabrication level model creation. And so we developed software to eliminate or drastically reduce the amount of time that's spent in creating the fabrication level of detail. And we did that by essentially BIM standards that kind of inform the designers as to how they should model to facilitate that model being useful to support fabrication. So it was a pretty basic set of rules, like you model wall panels like level to level rather than going the full height of the building. And then there were more subtle requirements, like for example, when structural engineers are indicating a framing type in a wall that would appear on the drawings, they would attach that in a particular way to the metadata of the model in a way that the software would then read that framing specification, and the volumetric definition of the wall would be geometrically accurate. And with that, we would be able to automatically lay out the framing and the placing of hardware so that wouldn't have to be done manually. So it's a custom application that would go from Revit. In this case, we were using HSBCAD as our framing fabrication software that would feed the factory. So just a little bit more detail into that approach. So here is just a map of design effort. So you see all of the different activities that sort of a fabrication level modeler would complete, including and then we assigned which activities can be fully automated, partially automated, or which would remain manual. And you see the kind of level of effort reduction that we've achieved over the, say, past, almost 2 years. So we're kind of at the 70% or so stage as of May. That's largely remained unchanged to date. So what's kind of interesting about that is from a sort of skills or experience on and this is specific to the sort of detailed design phase of creating that fabrication level model. So this was the team composition in January of 18. So novice is, kind of less than 2 years of experience, journeyman like 2 to 10, and expert beyond that. And we attached what skills are required to complete those tasks. And in January of this year, you see a pretty significant, this isn't the composition of the team today, but it's what would be ideally required given the level of automation. And so, as you might expect, what you see is a higher demand for sort of the expert skill level, because the software has kind of taken away a lot of the menial tasks that a novice would do. And what's really needed is sort of an expert that's able to handle the unique conditions and also QA/QC the output. And I think that raises some kind of interesting questions in terms of staffing and like pedagogically, like if you are a young designer entering the field, what does this mean as software starts to tackle some of the sort of novice level activities or like apprentice level activities. And I think we're already seeing this in a lot of the applicants and young talent that's coming into the design organization, where many designers actually have some sort of tool building capabilities. You know, most are coming out of university with some kind of, you know, scripting or advanced software knowledge, and that enables them to sort of make a contribution as sort of the technology experts, the tool builders. And so I think, I don't know, I'd be interested to hear others' experience with this that are working in the design area, but that's something exciting we're seeing, where those, we sort of have like hybrid designers that are, you know, young architects or engineers, but also are helping us to build tools to make them more process efficient going forward. And we're partnering them with very experienced designers who understand the rules and heuristics that are getting encoded into software. The final sort of part of
Forrest, I'm sorry, I just had one question. So with all of that automation, what do you think the design opportunities might be, given the Katerra approach to automate more of the design that is being done, so it's not as scary as it sounds?
Yeah, that's a great question, Zig. So I think I'm glad you brought that up. I think it's design, of course. There's, you know, performance, I think, is something that's very critical. And so because you have a higher level of automation, designers can essentially spend more of their time in higher level activities. For example, like defining the problems of like what systems they want to consider, or what range of options are interesting. And then with the automation, allows them to sort of like rapidly analyze those options or detail those options so that they can be better understood. And so the goal here, I mean, is that we want to make it easier. If we're designing, building products, we want to make it easier for the software to like configure those and like make them applicable to site conditions, and allow designers to spend more of their time on sort of quote unquote product development, looking at those more interesting challenges of exploring new systems and new ranges of options that they might not be able to consider in a traditional context, just because they wouldn't have had time or budget to do so. So this isn't intended to sort of like reduce the number of designers that we have on staff, but rather to reallocate them so they're sort of spending less of their time in like the detailing and modeling, and more of their time actually like coming up with system definition and requirements, and that's the idea behind it.
So have any of the, as you called, the more senior or experienced design team members shared that they're really excited to use the automated approach, or what are their emotions around it?
Yeah, so I think on the structural side, we've gotten a lot of, and that's probably where we're the most advanced. We've gotten a lot of great feedback, and I'll show a little bit of that later, in that being able to get sort of like real-time performance feedback is really valuable to the designers, because it allows them, of course, to understand the implications of their decisions and to be sort of like more interactive and more effective designers. We are exploring that on the sort of sustainability and energy side. And so that's, I think it's emerging. We still haven't developed the tools, but I think from a sustainability perspective, senior designers are pretty excited about it as well, because you know, of course, it's a multi-criteria problem that requires a lot of analysis to understand implications, and if we can make that more effective, then we do. And so in short, right, I think the senior designers are probably the biggest advocates for it. There was some, you know, there's some concern from like the more junior sort of like detailed designers, that they may feel that they're, you know, that somehow the software is going to replace their jobs. And I think that's where you really require like good partnership, right? Where they're involved in the solution, and they have skills that will not be, you know, immediately replaced. And I think it's more about making that a partnership. And obviously they have all of the domain expertise. So
Okay, great. Thank you.
yeah. I'm seeing quite a few chats, but maybe Margie, Zig, do you want to hold those until the end?
Yeah, why don't we keep on going? Because I think you're close to, well,
Done.
actually one is related to what we're talking about. This is from Tony Ranella. What are some design tasks and outcomes that have been most improved via design automation? And does the connection of novice design tool builder and senior designer accelerate professional development of the newbies?
Both good questions. As you might expect in terms of where are we having the most impact, I think there are parts of design that are very deterministic and rule driven. For example, laying out of framing is one thing, right? Where there are a series of rules that govern that. Those are, you know, the easiest sort of tasks to automate. And so things like routing of ducts, or, you know, laying out of framing, like those are where we've seen the biggest benefit, and that we can develop high degrees of automation there. And the second question is kind of talking about development of the newbies. I would say that's a great one. In fact, I think what it has resulted in, particularly if the newbies are tool builders, is like a very tight sort of mentoring and collaboration between the experienced designers that know the rules and the newbies that are encoding the system. And so from that perspective, I do think so, because it's, you know, it's basically forced a very tight collaboration between those two groups. So this, when we're talking about the interaction of design and production, and I purposely chosen like a, you know, relatively trivial example of this, but I think it illustrates the point. So here we have, you know, two different stud walls. From a structural perspective, they're almost identical in terms of structural performance in shear and bearing. So, you know, which wall should the engineer specify? And because, you know, this is not something that the customer directly experiences, we would, you know, we would like them to specify the more economical option. So in this case, and this is specific to sort of, this is a bit dated now, so this was the Phoenix factory, but costs, in each case, we see it's option B because of the equipment that we were using. It was significantly more efficient to build option B, but we were still having, you know, engineers that were specifying option A. And because, you know, maybe in the field or with their previous experience, you know, I don't think there was as significant of a difference. And, you know, option A has some advantages in that you have, like, you know, greater stud spacing, more room for coordination. But the basic challenge here is, how do you surface information to designers to allow them to make more effective decisions, in this case about cost? So our approach to handle this, and I think this is, you know, one of the advantages of being vertically integrated, is, you know, here's a sort of map of the different stations in the Phoenix factory. I don't think it's important to discuss all of the stations here. We have, you know, framing and blocking and sheathing and windows, et cetera, right? And so each panel that goes through this factory line, we record the time that it spends at each station and the materials that are assembled there. So because, you know, stud walls in particular, like, is a pretty parametric space, there's only certain spacings and sizes and openings. If you have enough historical data of this type, you can make a predictive model that will allow us to feed, like, any arbitrary sort of panel design into the production system and estimate fairly accurately what the total manufactured cost will be. And I think that enables some exciting sort of opportunities on the design side. And one of those is, and this is just a very simple website, right, where the engineer enters their required performance in shear and bearing for a wall, then the range of options that they're willing to consider for the design in terms of nailing and sheathing and materials. And when they submit it, the system then essentially recommends different constructions ordered by cost that meet that performance criteria. This is a relatively simple example for just like a single stud wall, but you can imagine this type of approach being applicable to other types of assemblies, and being able to extrapolate this to more like building scale decisions. So what's kind of exciting is you enable the engineer to just focus on what they understand in terms of performance, and the sort of system is helping them with cost. And this cost model is pretty dynamic. So I had never worked in a manufacturing environment, but the factory is constantly changing its processes and in some cases equipment. And so what is most efficient to produce is pretty dynamic over time. And if you have a system like this, it basically learns because it's constantly being updated based on the more recent historical data. And so what is most cost efficient 6 months ago may not be the current most economical option, and this system will constantly provide like the best data on cost. So we did a case study here that looks at design effort, which I think is sort of less important from a overall cost perspective. When we were trying to optimize the framing, we did, I would say, what's pretty typical on a structural engineering side of looking at, in this case, quite a few options, probably more than most projects look at, just because this building was going to be, productized and used more often. But here, with the automation, we can look at, this is at the building scale, millions of options. And that enables us, in this case, to come up with, a 10% reduction in the hard cost of walls. So again, not a huge margin in the difference, but I think, what I've kind of learned is like, it's not one big thing that is going to enable you to become sort of more competitive in this area. It's a lot of kind of little things like this that sort of add up to achieve some efficiency in the market. So that's, one thing that we've done for walls. We're exploring doing that for other things like, MEP detailing, routing of piping, et cetera. And what I'm excited about is that I think we could eventually bring this to more earlier stage decisions, which have a bigger impact on cost, like, unit design or massing of buildings. So that's one thing on the design automation. And then I have just one more sort of technology approach I'd like to discuss, and then we can open it up for questions. One of the challenges that Katerra had was actually, when we're purchasing material, being able to accurately predict material demand so that we could sort of negotiate better deals with primary suppliers. And in some cases, primary suppliers, so this is like buying lumber from the mill rather than from a distributor or lumber yard. Typically, you can get it from a primary supplier, like, roughly 20% cheaper. But that, in this case, could require like, having an accurate demand, 12 weeks or even earlier before it's needed. And so, so we developed a system that, since we have, the models are meeting certain standards, we're able to extract information from models. And in some cases, the design might not be complete. So we may have a volumetric definition of a wall, but we don't have all the studs laid out. But we're able to use historical data to fill those data gaps. So, if we built similar type of buildings before, we know roughly what materials are involved based on those volumes of, say, wall. And then we apply the automation to be able to generate a bill of materials, And then we surface that at a portfolio level so that we have like a dashboard of material demand over time for, say, the next 12 months. And that enables our materials team to have better information and negotiate deals with primary suppliers. So essentially, better reduction in some of the manual effort of doing QTOs. We get actually better performance than we get out of a manual QTO. And that enables our sourcing team to negotiate better deals. So that's something that is relatively new to me because I never worked on a sort of manufacturing or materials organization, but I think there's a lot of opportunities there of being able to leverage, BIM and automation to help with sort of the forecasting of materials. And it actually, makes it pretty, as anyone who's buying materials, like, that this is these numbers add up pretty quickly if you're buying a lot of material. So it justifies the investment in technology that can give you an advantage there. So that's, I guess that's all I had in terms of the presentation, but excited to take questions from the group.
Yeah, so we have a bunch of questions, so I'm gonna start asking.
Okay.
So this is from Eric Law. How many buildings or projects has Katerra used this platform approach on?
So there have been a few different iterations of the platform. There's what was called the K2. It was like the original integration of the multifamily platform. Their projects built, I think there are 5 or 6 developments that have been completed, and there are a couple that are still in progress for the sort of K2 platform, which was a 24 unit garden product. We have a next generation of that's called K3 that will be, we're actually, building that in Tracy. And I think it'll go vertical in March of this year. So kind of finalizing the development of the next generation of the multifamily product. There's an office platform that's in development and will probably finish design in the middle of next year. So that product is still a ways before actually going vertical. I would say, at least a year.
And if you could answer this as objectively as you can, this is from Dean Reed, fellow board member. Have you seen significant improvement in the quality of the final product delivered to the customer?
Good question. I would say Katerra is not there yet in terms of delivering an improved quality product. I think, with an industrialized construction model, the potential is there to have sort of better quality control than, kind of site build, but I don't think we're there yet. So all of the, to just provide a little bit more information there. So Katerra, when we started the factory in Phoenix, to keep the factory busy, we took on a lot of third-party designed work that wasn't really designed to be fabricated. It was, stick-built work that we decided, we took on a fabrication job. And so because of that, there was like quite a variety of, say, wall and floor panels that are going through the factory. And it was pretty challenging because none of the sort of DFM rules the design was already done and we were just fabricating what had been designed. And that led to, I would say, quality challenges because the production system wasn't really set up to handle that variety. But as we're getting better with understanding capabilities and being able to define the DFM rules for what Katerra can efficiently and manufacture to a high degree of quality, I think we're seeing, improvements to quality in that regard. So Dean, yeah, I would say potential is there. As I think, most people recognize that industrialized construction offers that opportunity, but I don't think we're there yet.
Okay, great. So this question is from Walt Terry, and I'm gonna just shorten the question. But what do you see as the current bottlenecks given the new process flow, moving some of the work offsite and doing some of the work on-site?
Great question. Wow, where to start there? I think sort of one thing that we've, I guess, struggled with, I mean, I don't know if others, so there's kind of a trade-off between the order in which you'd want to fabricate panels from like a manufacturing efficiency perspective and the order in which they're needed on site, right? And so I think we're kind of still evaluating some of those trade-offs where you would like to have very little handling on site and things like the truck holding times, if like the crane is picking up those panels, and like whether you can take racks off so that the trucks can depart. But I would say like the sort of crane pick time of like actually setting the panels is a bottleneck, right? Like panel lengths and like how can you reduce the number of panels has a decent impact on the schedule. I'd say that is that is probably you have the traditional bottlenecks as for the normal levels of completion that we're having on site, but I would say that that's something that is critical path, is like trying to essentially optimize sort of panel size and setting to enable that to be done more efficiently.
So the next question is from Larry Booth, and I had a similar question. Will this software be adaptable to other building types, and will it be something that Katerra will monetize to the general marketplace?
So I think with regard to the first part of that question, I think that a lot of the software I think is applicable to general building types. I mean, things like automated routing of ducting or wiring is, I think, pretty generally applicable. In terms of whether we sort of commercialize that software, there's been I think a change of direction a little bit there, in that some may be familiar with a software called Apollo that Katerra had made some announcements around potentially spinning off a platform that we would commercialize on the software front. We've recently made the decision not to spin that software out and to use it internally. I think that's the right thing to do for a couple of reasons. One is, we actually want to ensure that the software provides value, and if it does provide value to Katerra, I think that's will help with sort of the sale and adoption of the tool. If we have those stories to tell about how Katerra has used the software to its advantage, that software is much broader than just design automation. It's more of an end-to-end platform, and we are just starting to use that internally amongst some of our business units on the construction side. We haven't yet integrated it with some of the design automation work that I showed. So I hate to not be more specific, but I think that's a TBD. I think we have to actually use the software, see if it delivers on the value that we think it will, and then probably evaluate, I would say, in a year's time whether we think that's something that Katerra should commercialize. But no current plans to offer a commercial product.
Okay, great. So I do want to apologize up front. There's a ton of questions, and we'll try and get to all of them that we can. Next one is from Steve Burrows. Using the Spitfire machine gun analogy, is there a target percentage savings versus traditional market pricing for the multifamily product?
Yeah, so there is. So I can't share the specifics of those numbers, but we did look at like what could be saved from you have these trade-offs, right, between like materials, labor savings, right? Then you have logistics and like the OpEx of the factory. So I guess, yeah, we do have those numbers, but I guess we're not advertising those.
Okay,
Sorry.
we'll set up a separate session for that.
Yeah.
So this question is from Ray Boff. How do you determine which products to R&D and newly introduced to your delivery model versus not?
Yeah, that's a great question. I think so. Currently, we do have like a sort of like ROI type analysis where we look at different research initiatives and we try to sort of prioritize their impact and cost of development. The way that's currently done right now is like a pretty small group within the CTO organization.
Mm-hmm.
We're working to try to democratize that, right? So if anybody in the company that has an idea that there's somehow a path for that to be heard and analyzed where appropriate. I know, I mean, I had worked at Arup previously. Arup had a pretty good system by which you could have like a sort of grassroots effort for ideas. We're starting to develop that, but right now, it's like a pretty small group, but we do that sort of business case analysis, and that's the sort of justification of what we choose to invest in. One more comment there, which is, Katerra early on had quite a lot of investment in sort of hardware. So things like, HVAC systems or new building materials. I mean, we're still heavily invested in CLT as a material, but I would say the focus has shifted recently more to the digital side rather than sort of like material and hardware innovation. I think we're roughly like 80% digital now or so.
Okay, great. So the next question is from Samin Nasa. Could you talk about the regulatory processes and how Katerra navigates it on individual projects? Are there any pre-approved processes for any of your products?
Yeah, great question. I am not the expert there, but what I do know is, most states have a factory built housing program that sort of enables that pre-approval. And so Katerra is actively pursuing that in a number of states. And so, that's what I'm aware of in terms of pre-approvals there. I know it's more complicated than that. And if you'd like to reach out, I can put you in touch with, we do have a lead on the regulatory side that may be able to provide more details, but that's what I know.
So this question is from Luis Perez. Do you find that developers are interested in this process, or does it take a unique project and developer to implement?
Another great question. I do find that, so I think developers, of course, are interested in the certainty, right, of being able to sort of configure sort of a development to their needs and understand sort of costs and timelines associated with that in a sort of provide more certainty in that area. So I think that's a big value driver for developers. I think in terms of whether it requires a certain type of developer, I mean, I would just say, I think, Katerra is trying something new. And I think, because it's new, some developers, you assign some risk, right, to partnering with a company that's doing something new. So you have to have, I would say, the right developer who's willing to sort of take that gamble. And I think that the calculus on the customer side is that it's a more long-term arrangement, right? Where if we can develop that partnership, that benefit will pay off over time. So I think, I would say honestly, that's the type of developer, right? You have to be, willing to try something new.
So this is from Alexander Zhao. What is key in your product platform? Data technologies or processes?
I think it's tough to kind of make a distinction between both. Both I think are essential. I would say, one of the biggest opportunities in productizing a building is that you can learn from sort of iteration and iteratively refine the process and the process. And I think collecting data is essential to that. So because we're building similar things over and over again, we're able to collect, I'd say, data that is kind of like not confounded by all of the other factors that make it difficult to sort of like distinguish the root cause of changes in data. So I think that's one of the things that Katerra is investing heavily, is being able to collect that data, both in the factory, as I showed, but also in the field, so that we can iteratively refine. So I think process is important for all industries, but we're really trying to make an effort on the data side to be able to sort of use that as a data-driven learning tool. Still a lot of work to do there, but I would say that that's central to this approach. Sorry, I couldn't draw a distinction between the two, but I think you need both to be effective.
Okay, and I apologize for not getting all the questions asked, but we unfortunately ran out of time, and I'll turn it back over to you, Margie.
Great. Thank you so much, Forrest and Zig. This was such a great and terrific presentation. We're now concluding CIDCI's online salon. Please join us on October 5 for a lively conversation with healthcare owners for discussing what the new next normal looks like on the first day of CIDCI's 5-day fall forum. Sessions are free, but registration is required. Sign up to join the CIDCI mailing list by subscribing at cidci.org. Thanks to our whole audience for joining us. And as always, if you've got thoughts or comments, please reach out to us via the CIDCI website's Contact Us link. And special thanks to Monica Zwisler for keeping us all on track, Zig for helping us frame the conversation, and Forrest, most of all to you, thank you for your time and terrific presentation. Be safe and see you all soon. Thank you.